Hey makers, welcome back to Hub360 Embedded Sphere, your go-to spot for embedded systems, IoT, and affordable electronics. Today we are building a temperature monitoring system using an ESP8266 WeMos D1 Mini board, a DS18B20 temperature sensor, and the ThingSpeak IoT platform. You'll be able to monitor temperature readings in real time from anywhere in the world, log temperature data to the cloud automatically, visualize your data with beautiful graphs on ThingSpeak, and understand how to work with one-wire sensors and IoT cloud platforms. All components are available at hub360.com.ng, tested, affordable, and shipped nationwide. Let's get started. This project is a complete IoT temperature monitoring system that sends real-time temperature data to the cloud. Here's how it works. It senses temperature through the DS18B20 sensor and accurately measures temperature in Celsius. It connects to Wi-Fi through the ESP8266 for internet access. Then there's cloud logging, whereby data is automatically sent to ThingSpeak every 20 seconds. ThingSpeak is the cloud platform we are using for this project. Data is then being visualized as ThingSpeak creates real-time graphs and stores your temperature history. It can be accessed remotely, and it enables you to monitor your temperature data from anywhere using ThingSpeak web interface or mobile app. All happens automatically and wirelessly. Now let's understand more about the ESP8266 WeMos D1 Mini. Before we dive into the wiring, let's take a closer look at it, the Wi-Fi enabled brain of this IoT project. The ESP8266 is a low-cost Wi-Fi microchip with full TCP IP stack and microcontroller capability. The WeMos D1 Mini is a compact development board built around this powerful chip. The key feature it has is that it has inbuilt Wi-Fi, which enables connectivity for IoT projects. It has a 160 MHz CPU for fast processing for real-time applications. It also has a 4 MB flash memory, which is plenty of space for code and data. It is Arduino compatible, which means you can program it using familiar Arduino IDE, just as we are using this project. It has 11 digital input-output pins labeled D0 to D8, TX, RX for easy identification. It also has one analog input pin identified as A0 pin for reading analog sensors, and micro USB port for power only. In battery management, it has a built-in LiPo charging circuit with one Li-ion battery holder casing attached to the board. The compact size is perfect for portable and space-constrained projects. Here's something that caught me during this project, and it might surprise you too. The micro USB port on this WeMos ESP8266 board is for power only, unlike most development boards where you can program directly through USB. This particular version requires an external FTDI programmer for uploading code. This matters because you cannot upload sketches through the USB port. The USB port only charges the battery and powers the board. You must use an FTDI USB to serial adapter for programming. This is a common design on battery-focused ESP8266 boards, like the one we are using here. And here's how it works. The board can be powered through the USB port or LiPo battery. The FTDI module is connected to RSTS pins for the ESP to program, and then once programmed, it runs independently with battery or USB power. This design choice makes the board extremely portable and battery-friendly, but adds an extra step during development. Don't worry, I'll show you exactly how to set it up. The components I use: one ESP8266 WeMos D1 Mini or compatible ESP8266 board, then one DS18B20 temperature sensors, waterproof, and then one 4.7 kilo ohm resistor, jumper wires. Then you need a ThingSpeak account. All components here are available now at hub360.com.ng. Now let's go into the connections. Connecting the temperature sensor, the DS18B temperature sensor, to our ESP8266 board, And first, we have to connect the 4.7 ohm resistor between VCC and ground of the DS18B20 sensor. There you have it. Then now we connect our VCC to the 3.3 voltage. Then we connect our data pin to D4. Then we connect our ground to the ground on the ESP. It is important you connect a 4.7 ohm resistor, kilo ohms pull-up resistor between VCC and data pins. Then now we connect the FTDI programmer to our ESP. Now we are connecting our FTDI programmer to the ESP8266 to program it. First, we start by connecting the 3.3 voltage pin on the FTDI programmer to the ESP board. But in this case, we will not be connecting it because it's not going to be useful. So we continue by connecting ground to ground. Then we connect TX to RX. TX on the FTDI to RX on ESP8266. Then we connect the RX on the FTDI module to TX on ESP8266. Important things to note: set FTDI jumper wire to 3.3 voltage mode and not 5 voltage because it will damage the ESP8266. Connect USB cable to WeMos board for power. FTDI is only used for programming, not power. Ensure common ground connection between FTDI and board. Okay, let's go through the code. We start by including the necessary libraries for Wi-Fi temperature sensing and one-wire communication. First, we enable Wi-Fi connectivity for internet access using the ESP8266 Wi-Fi.h library. Then next, we handle one-wire communication protocol using the one-wire.h library. Then next, we also simplify working with DS18B20 sensors using the Dallas temperature.h library. And then in the next section, Wi-Fi and ThingSpeak configuration section, we replace this place here, with our actual Wi-Fi name, password, and ThingSpeak API key. Then the next section, the DS18B20 sensor setup, we create one wire instance on GPIO pin 2 or D4 on the ESP8266 board, and then we create Dallas temperature object for easy sensor access. Then in the Wi-Fi client section, we create a Wi-Fi client object for HTTP communication with ThingSpeak. Then we now go to the setup function. In this section, we initialize serial communication at a baud rate of 115,200, and then we start the DS18B20 sensor. And we also connect to Wi-Fi network and show connection status and IP address on the serial monitor. The main loop function section, this place, we request temperature from the sensor, and then we read temperature in Celsius, print to serial monitor, and then connect to ThingSpeak server. Then we also send HTTP post requests with temperature data, and we wait for 20 seconds before next reading. Then we go to the ThingSpeak setup. This area, the ThingSpeak setup, that's that with the code. That's that. Well, now let's set up our ThingSpeak account. So first we go to ThingSpeak and then you sign into the account. Sign into the account. I'm going to be using a free account. And so once you have gotten into the account, you now click new channel. In my case, I've already created the business, so I won't be going to the detail of that. And then after clicking new channel, you enter your channel name. Enter your channel name, and then you can enter temperature monitor. It's your channel name. So, and then you will now enable field 1 here, and then name it temperature in degrees Celsius. So let's do it. Temperature. And then you can now click on Save Channel. Now to get your API key, you go to API keys. Then you copy this right API key, copy this one. You don't generate new API key, just copy this one here. And then after that, you now paste it in the code where it says your right API key, in your Arduino code, where it says your right API key. You now paste this code there. And then you can now go on, you now go to private view. After you have uploaded the code, now go to private view and then watch your live temperature displaying here in form of charts. You can also click public view to share your channel publicly here, and that's it. So let's upload the code now. Before uploading the code, you connect your USB cable to WeMos board for power, then monitor the operation on your serial monitor. You should set the baud rate to 115200. Then you should see messages like connecting to your Wi-Fi, and finally you see data sent to ThingSpeak. You also see your IP address. Then now verify this on ThingSpeak by going to your ThingSpeak channel, refresh the page, and you should see the temperature and data points appearing on your graph every 20 seconds in your free account. Let's take some troubleshooting tips. Upload failed. No DFU capable USB device available. The solution to this is that the USB port on this board is power only and it's not for programming. We must use an FTDI programmer. Ensure FTDI is set to 3.3 voltage mode. check TX-RX crossover connections. Your TX to your RX and your RX to your TX. Hold boot button during upload when connecting appears. Then another problem, FTDI not powering the board. Your solution to this is FTDI typically cannot supply enough current for ESP8266. Use USB cable connected to the board for power. Connect FTDI for programming, only GND, TX and RX. Ensure common ground between FTDI and board. Then wrong board selection. The solution to this, do not use ESP32 dev module as your board. Select low-link WeMos D1 R2 and Mini for ESP8266 boards. If you don't see it, install ESP8266 board packages. You can get that from the File and Preferences Additional Board Manager URL, and then you add the link. Then you go to your tools and your board manager, install ESP8266. Then another problem, Wi-Fi connection failed. The solution to this, double check SSID and password. It's case sensitive, and you also ensure Wi-Fi is 2.4 GHz. ESP8266 doesn't support 5 GHz. You also check Wi-Fi signal strength in your location. Verify Wi-Fi has internet access. Try moving closer to your router. The another problem, temperature reading minus 127 degrees Celsius. The solution to this is that this simply means that your sensor is not detected. Actually, what you see is that you check wiring connection, the VCC, the GND and the data. Verify 4.7 kilo ohm pull-up resistor is connected between your VCC and your data. Try different GPIO pin and update one wire bus definition. Test with different DS18B20 sensor, maybe 40. The another problem, data not appearing on ThingSpeak. To solve this, you verify right API key is correct. You check serial monitor for data sent to ThingSpeak message. Ensure board has internet access. And then ThingSpeak free accounts, minimum 15 seconds between updates. So every 15 seconds you will be getting updates. You are using a free account. Then you check ThingSpeak status page for service issues. Refresh your ThingSpeak channel page. Then connection timeout errors. The solution to this, increase delay between readings. And then check internet connection stability. Verify firewall isn't blocking outgoing connections. Try using different Wi-Fi connection and network. Then sensor reading fluctuations. And the solution today, ensure pull-up resistor is correct. Your pull-up resistor you'll be using for this project is 4.7 kilo ohms. Use shorter wires. Long wires can cause noise. Then add 0.1 microfarad capacitor between VCC and ground near sensor. Check for loose connection. Shield wires if in electrically noisy environment. And that's it. Your own ESP8266 IoT temperature monitoring system with ThingSpeak. You get real-time temperature monitoring from anywhere, cloud data logging and storage, beautiful graph visualizations, and understanding of one-wire sensors and IoT platforms. Perfect foundation for weather stations, greenhouse monitoring, house automation, and industrial sensing projects. Key lessons learned here is how to program ESP8266 using FTDI when USB port is power only, working with DS18B20 one-wire temperature sensors, sending data to cloud IoT platforms, troubleshooting common ESP8266 programming issues. And if you're enjoying this project, hit like, subscribe to Hub360 Embedded Sphere, and share it with a fellow maker. All parts are available at hub360.com.ng, tested, affordable, and shipped nationwide. Until next time, keep building, keep innovating.